Today in class, there was a question that I was hoping to solve with voltage division, and I let you guys work on it. I have the feeling a lot of you had problems. I only saw 2 people with the right answer, so I'm gonna solve a harder problem. In class, there were only 4 resistors and a power supply. So here I added 2 resistors and I added questions that were not in class. So in class, it was just like, if VB is 16 volts, what's VS? So what I'm going to use to solve is similar to what I'm expecting you to use in case you encounter this in an exam. That was an exam question, actually. So this, first let's talk about VB is 18 volts. This only means that this nodal voltage is 18 in comparison, or against ground. So this is what the 18 volts are. On that question, I think one of the confusing things is that there were currents all directions here. This way, that way. So there's currents going up and down. These currents on these resistors only mean that if I were to measure this current, then I was also measuring the voltage this way probably, and then this way, and then this way. If I told you the voltage across the 2K is 18 divided by 9 is like 2 volts. So there's a chance this would be 2 volts. Across this would be minus 6 volts, and this would be 8. Is that true? 8 plus 6 is 14 plus 6, 16. So, no, there's something wrong. Oh, this is 4 volts. So today we talked about voltage division, and because VB 18 volts is over the 9K resistors, I know that there's 2 volts for each 1K resistor. And it's in this direction here. And therefore, I know for sure there's 4 volts here, there's 6 here, and there's 8 here. So these are the voltages, how they split up, among these 3 resistors. So 4 and 6 is 10, 8 is 18. And what happens is, because all these are in series, all these branches are in series, I know that these are VA, VB, and VC are confusing, but they are nodes. So they are just labels from Circuit Lab. That's how Circuit Lab labels nodes. So what happens is, because this is in this direction and this is positive, I'm going to keep that convention. And I'm going to label everybody else here. So 1K is going to do this, and it will have 2 volts. 5K will go in this direction. And look, this is against what this current was saying, and it's 10 volts in this direction. And 6K also, I'm disregarding this, will have 12 volts in this direction. On the exam, that's all you need to do. If my question was just VS, what happens is, this is the negative, and I'm adding 12, 10, 18 is 22, plus 18 is 40, plus 2 is 42. So what happens is, VS is minus 42 volts. Why minus? Because this is the positive side and this is the negative side. So really, I was thinking to myself, I wanted a 42 volts in this direction here, 42 volts, and then a ton of resistors there. You can sum all them up, which will be what, 26K, and there's 42 volts there and 42 volts here. If, however, you switch the power supply, which I did here, then it's minus 42. The harder question now is VC. Actually, I'm not sure it's harder, but you can do it many ways. So not many. I only know how to do it 2 ways. So VC means I'm asking, what's this voltage in relationship to ground? So the easiest way that I know is 18 plus 2. So my easiest answer to that question is VC is 20 volts. However, you could go from here, VC to ground, And you could say from VC, oh, actually these 20, you can say VC is 2 plus 18 because I'm encountering a plus and a plus. But now let's go this way here. I'm going to change the color. Do I have a purple? I don't have a purple. I have a pink. So I'm going to now go with the pink this way, like we did nodal voltages, voltage drops. And from VC, I'm going to say VC is also minus whatever I found for VS, minus 12 volts, minus 10 volts. So it's minus 42, minus 22, which is also 20 volts. So minus 42 is 42, minus 22 is 20 volts. Now here I'm changing VA to be minus 10. And this is disregarding VB as 18. So if I made V8 minus 10, I'm gonna let you guys do this, but I believe VS turns out to be 42 volts because I'm just changing the sign of the of this drop across the 5K. I hope this helps with voltage division and with an exam question that you could be asked to solve.